Hello, my name is Michael Kishlar, and today I'll be updating you on the progress of the low-budget sensor array here in France. This week, we primarily wanted to focus on 1. Having a reliable environment in that which we could test our thermocouple to ensure that its readings were indeed within 1 degree centigrade, as well as improving upon our design concept for the thermal barrier. As Jake touched upon previously, we had a design that we had the thermal barrier as well as the phase change material inside that would provide an environment that the circuit board would not get too hot, but actually it consisted to maintain its low temperature as time went on. We were very proud of how this turned out and wish to further implement this design in the future in our drawings. This week we also had the opportunity to give President McNulty a tour of the lab space, as well as an overview of our project as time went on. When doing our temperature readings with the hot and cold water, we didn't find inconsistencies with our hot water test, but rather solely with our ice bath test. Initially, we thought this might be a bug with our thermocouple, but after research, we realized there might have been inconsistencies with the way we partook in our temperature readings in the ice bath. Initially, we didn't even have enough ice to keep the temperature at a low constant rate. We had enough ice to keep it cool, but not at a stable temperature. Also, when doing our readings with the thermocouple, we realized we had to have it be at a consistent location within the cup. It couldn't be too high close to the ice or too low, and it also couldn't be too close to the glass on the edge. After using these industrial standards, we were happy to find that our thermocouple did indeed give us constant readings. However, we are still having an issue with heating up the circuit itself. If one was to induce heat on it, our readings for the thermocouple would vary slightly. This is a problem that we're going to have to address, seeing as how when we put the circuit in the oven, it's going to exceed high temperatures, so we have to make sure that even if the circuit board gets a little toasty, that it stays consistent with the thermocouple temperature reading. Again, we are happy with our thermal barrier, and phase change material has been able to keep the temperature of our circuit board to a minimum. This, along with our wooden interior and metal alloy finish of our thermal barrier, has been very vital to keeping the costs down, seeing as how inexpensive materials like wood are. Going forward, we are confident with this design and wish to cater to our customers' needs depending on the desire that they have. For instance, Tony has begun sketches for different sizes of thermal barriers, depending on if they wish to use an Arduino Uno or an Arduino Mega. We want to be able to cater to that specific need. Finally, going forward, we have begun researching various projects that are also looking into tunnel ovens and their sensor arrays. One project being that in Reading PA, Project Scorpio. We believe looking at previous work and expounding upon that is very important for the effectiveness of our design, along with us being able to incorporate our needs for a low-cost version for the public use. We're confident that we're headed in the right direction and can't wait to update you further. Thank you. Done the good. Hello. Number 3! These aren't even my glasses. Patience. I don't know about that. A good French water. Cost. I'm saying Again, we are happy with how our thermal barrier and phase change material has I think my first take was pretty good, actually. Yeah, we'll go with that. Oh my gosh. Oh la vache. Oh la vache. Low carbon footprint. Yeah, people love that.